Hi, my name is Sunshine Wynn, and I did my project research on science-based simulations. Is there a place for it in the classroom? These were the 4 guided questions I used for this project. I looked into what other educators used for science-based simulations, the limitations and positive aspects of these, as well as the best practices for using them within the classroom. Research led me to a few sites: PhET, EduPlace, udel.edu, as well as Minecraft. My case study consisted of 3 fifth grade students. We met on 10 different occasions to work on each simulation for 15 minutes each. Then I used my matrix in order to guide my data collection. I gave the students a survey at the beginning to assess their pre-existing knowledge of simulations. Then I instructed them on the simulation and let them explore. At that time, I did my observations to record engagement, enthusiasm, as well as interaction. Following each simulation, I then interviewed the students and took notes on what connections they were able to make. I then gave them a post-simulation survey in which they were able to relay to me their understanding of the different simulations, as well as the connections that they could make with those and actual hands-on experimentation. And to finalize it, I also sent a parent survey home so that the parents could ascertain information that the students were able to share with them about the simulations at school. So then we move on to our limitations. These are the ones I discovered. If you were to do a simulation on the computer in order to illustrate something that may be more difficult to replicate, like launching a projectile, then you would have an easier time understanding the outcome from different approaches, such as weight, angle, or force. But when you actually do the experiment in real life, there are other factors that can alter the outcome, such as weather or how well you put the prototype together. This is something that the students have to experience hands-on. Then there's computer miscalculations. We are human after all, and humans are the programmers. We are subject to error, so there are going to be miscalculations. And then finally, if students don't have a solid understanding of how to ask good questions as they're exploring and learning, they'll struggle in science inquiry. So being able to understand those simulations and make those connections is extremely important. So then we move on to the positive aspects. If we would like the simulations we use to be of high quality and cover the areas we are studying, then we need to do our own research and find appropriate sites that can facilitate a strong learning environment. This supports the learning we want to take place. Students understanding that adults also engage in simulations for multiple professional purposes will demonstrate the importance of their use. Using simulations to test before actually doing something like pilots do, or doing an experiment that would otherwise be unsafe, like volcanic simulations, underwater simulations, or even space exploration, is something that is pretty unfathomable for students. In order to have those positive outcomes, research supports that math and science simulations, when it's used with immediate feedback, constant discussion, such as among the whole class, weeding out misconceptions and other problems, and guided questioning from both teacher and their peers, can be extremely beneficial. Follow up with an actual lab or hands-on science exploration. Make connections from the simulations to the real-world applications. So this helps to guide the students to understand that these simulations are just that they're simulations. They're not the actual experiment. Upon completion of this project, when analyzing the data, I discovered that students were more engaged. Their interactions were very positive and supportive. They made connections through discussions that we had, as well as through the interviews that I had done with them individually after each simulation. Through the post-survey, students informed me that some of the simulations weren't as enjoyable. These they felt were a little primary. Then 2 of the 3 students were adamant that simulation should only supplement and never replace hands-on experimentation, which they expressed on their own accord. One student compared it to pilots and said that you wouldn't want a pilot who only did simulations to actually fly you anywhere. So in conclusion, the simulation tools are an application we can use throughout our entire lives. When used appropriately, simulations can benefit student engagement in learning as well, and that simulations allow for lab experiences that are faster, cleaner, safer, and allows for exploration when the equipment is unavailable or the environment is unattainable, such as going to the moon or going underwater, things of that sort. I thank you so much for your time, and I hope you will give simulations a chance.